So, in continuation with the restricted class, the end of the line voltage support to prevent the voltage instability. In the last class, we discussed about what is meant by voltage stability and what is meant by what is instability, what are the causes of voltage instability. So many things we have discussed in the last class. In that, we observed that in case of inductive load, voltage stability decreases, inductive load voltage stability decreases, in the capacitive load, voltage stability increases. That is the final conclusion from this stability concept, which I have already discussed in the previous section. Now, with the help of these compensation devices, how the voltage stability can be achieved. That means voltage stability achieve చేయమంటే ఇండైరెక్ట్ గా voltage instability ని మనం రాకుండా చూడడం. That means to achieve the voltage stability, that means to prevent the voltage instability, we are inserting one voltage compensation device is near to the wire compensator, near to the load. So here the end of the line voltage support is very helpful for in case of radial line system. In case of radial line system, the receiving end voltage is very less. So many disturbances occur at the receiving end side. That's why we are connecting the one compensation device or wire compensation device or shunt compensation device near to the load. This is nothing but here wire compensator. That is in our topic, that is nothing but reactive power compensation device. You know that the reactive power Q is equal to the units of reactive power is kVAR or VAR. That's why the reactive power compensation other name is the wire compensator. Here we are using the shunt compensation devices to mitigate the voltage drops in the loads. Otherwise, voltage drops reduce చేయడానికి మనం జనరల్గా ఈ wire compensator devices అనేవి యూజ్ చేస్తాం. So here while we are connecting the voltage compensation devices, it supports the reactive power. Therefore, it reaches the demand of the load. For example, the QD is the reactive power demand of the load, and QS is the reactive power supplied by the source. And the source నుంచి వచ్చే supply నుంచి వచ్చే reactive power QS అనుకుంటే, and demand అంటే reactive power load కావాల్సిన demand ఎంత ఉందనుకుంటే, that is the reactive power demand of the load is QD, and supplied that means reactive power source which is from the supply source is QS, and QR is the reactive power. QR is the reactive power required from the wire compensators, otherwise wire compensator output reactive power ni QR అనుకుంటాం. For example, here the demand of the reactive power is, for example, I am the load, that is here Z is the some load, I am the load. For example, I am the consumer of the load. So if the demand of the load is, for example, for sake of simplicity, I require 4 VAR. I require demand of the load is, and the load cost demand of the 4 VAR. But the Q supplied from the sources, but from generation side, the available reactive power is, for example, 3 VAR only. Demand we require 4 VAR. From generation side, we require only 3 VAR. So how much is the deviation from 4 to 3? Only 1. That is 4 minus 3, 1. That means we have to supply 1 VAR additional supply along with the source. Already generation నుంచి వచ్చే సప్లైతో పాటు జనరేటర్ నుంచి వచ్చే రియాక్టివ్ పవర్తో పాటు అడిషనల్గా ఒక ఎక్విప్మెంట్ యూజ్ చేసుకుని మనం ఇంకో 1 VARను సప్లై చేస్తే మనకు కావాల్సిన లోడ్ కావాల్సిన డిమాండ్ అనేది మీట్ అవుతుంది. అంటే 3 అనేది సప్లై చేస్తే విచ్ ఈస్ నాట్ సఫిషియెంట్ టు డ్రైవ్ ది లోడ్. దేర్ఫోర్ we require one reactive power, that is 3 plus 1 VAR. Therefore 3 plus 1 is equal to 4. That means Q demand is equal to QC plus QR. That is QS plus QR. QS is the 3 and Q required or Q supplied by the reactive power component is 3 plus 1 is equal to 4. Therefore Q demand is already 4. Therefore 4 is equal to 4. That is the importance of this reactive power compensation. So while compensating these, providing this reactive power, which indirectly supports the voltage, that's why in this shunt compensation devices, it supports the voltage at the receiving end while providing the reactive power. This is the importance of these reactive power compensators. In this, the reactive power compensation device, it may be variable impedance type, that is, it may be inductance type, it may be capacitance. While capacitance, the stability increases, while inductance, stability will be decreases. This is the problem in the variable impedance type of compensation devices which is used in this receiving end side at the end of the radial transmission line. అంటే రేడియల్ ట్రాన్స్మిషన్ లైన్లో ఎండింగ్ పాయింట్లో వేర్ కంపన్సేటర్ ఉంటుంది. ఆ వేర్ కంపన్సేటర్ వేరియబుల్ ఇంపిడెన్స్ టైప్ అనేది మేబీ ఇండక్టెన్స్ ఉండొచ్చు, కెపాసిటెన్స్ ఉండొచ్చు. మనకు పర్పస్ బేస్ చేసుకుని ఇండక్టెన్స్ కానీ కెపాసిటెన్స్ కానీ యూజ్ చేస్తాం. సో ఇన్ దిస్ వే the shunt compensation devices which can improve the that means it will provide the reactive power, then it will improve the voltage profile of the system. For example, in the last class we discussed about without any these compensation devices we discussed the system and also P versus V curve. But in this class we discussed about while connecting the shunt compensation devices, what happened to the P versus V curve. Now observe the P versus V curve of the this particular system while connecting the shunt component devices. This is the load power. That means whenever the load increases and the voltage drop will be decreases up to some certain critical point value. After that, the voltage will be decreases a very faster rate. The same happened at this power factor, for example, 0.85 lagging, and this is the 0.95 lagging. This is the unity power factor. This is 0.97 leading, and this is 0.9 leading. Depending upon the power factor, the voltage will be changes with respect to load. That means load and power factor, which will decide the voltage profile of the system. So here one thing you can clearly observe that in case of the without compensation devices, while the same system without any compensation device, while increasing the load, the voltage will be decreases up to critical point. After that, after critical point, voltage voltage decreases very faster rate. After critical point, voltage decreases very faster. But here in this diagram, you can observe that the curve shape is similar to the uncompensated devices, but here in compensation devices, what happened is while increasing the load, voltage is not decreasing very faster rate. It maintains the constant voltage at the rate of 1.0 per unit. That is the importance of compensation. Without any compensation devices, while increasing the load at a particular power factor, voltage decreases. But while with the help of these compensatory devices, we are maintaining the voltage 1 per unit. That is the difference between uncompensated devices and compensated devices. That means while we are connecting the shunt, this is the advantage. That means irrespective of the load, we are always maintaining the constant voltage provided to the load. This is that's why it maintains the constant voltage as the buses. This is the advantages of shunt component devices to prevent the voltage instability. Okay, so we will continue the next topic in the upcoming section.